Thanks for coming. By way of introduction, my name is Steve Lyons. As Professor Eager told you the other day, I'm a lawyer here in Boston. I'm actually a particular kind of lawyer. I'm a trial lawyer, which means I go into court and I actually stand up and try cases in front of juries, which also means I know very little law. Except as it relates to actually trying cases. So I'm not the kind of guy that you come to and ask to write a contract or a will or a licensing agreement. I don't prosecute patents or intellectual property. And by prosecute, that means fill out the applications, draft the claims and things like that. I'm the guy that kind of comes in with a broom after everybody has made mistakes and tries to clean up the mess. So think Perry Mason, but doesn't know as much law as Perry Mason does. But I actually try cases, and that's about 1% of the lawyers out there. And Professor Eager's right, I've tried cases everywhere. I've done intellectual property cases in the United States Supreme Court and the Federal Circuit Court of Appeals, which is kind of like the main showroom for intellectual property cases. And I went to MIT, at some point, I decided I didn't want to be what they were trying to make me be, and so I went off and became a lawyer, thinking that was probably the best way for me to sort of fit into society and contribute something. While most of my classmates went out and made millions and millions and millions of dollars, every year I used to get postcards from my classmates with them standing in front of their mansions. Because they had developed an algorithm that does a trade 1/4 of a second faster than everyone else. And I'm sitting there with a rented typewriter, with 2 fingers, getting my start practicing law. But it's paid off, I guess, because I feel at least useful doing what I do now. I represent people who are involved in controversies. I tend to represent the little guy against the big guy. I tend to represent people in intellectual property cases who are the inventors, who are the people that come up with the intellectual property that needs to be protected or is being infringed on. So that's kind of like what I do for a living. And Professor Eager has given me the opportunity to come back here because we've sort of found a gap in the curriculum. As I said the other day, we teach you folks to be the best researchers, writers, inventors in the world, but we don't tell you or teach you how to protect your intellectual property. And there are many ways that the law and technology interface. As engineering students, as structural engineers, you may be sitting there saying, "Why is some lawyer standing up in front of me talking to me? What does he know?" And all I can tell you is that in almost every phase of your future work, it will interface with the law. If you're a structural engineer and you're trying to figure out how to construct a beam that has to span a specific distance and hold a certain weight, there are rules, there are regulations, there are standards, there are laws that you have to follow. And in almost every way, you will find that your careers in the future will interface with the law. Sometimes when it has to do with intellectual property. So you come up with an invention that you need to protect because it's going to make you a millionaire. But you'll find that as soon as you come up with a really good invention, a lot of other people will try to steal it from you. That literally is the way of the world. And there are other ways that the law and technology interface. Imagine the computer programmer who designs a computer program to fly an Airbus, and because of some flaw in the program, it flies itself into the ground instead of doing what the pilots tell it to do. Or a Ford Motor Company Explorer that explodes with rear impacts. Or a piece of surgical mesh that causes terrible complications those are examples of products that have defects in them, which you as material scientists and as structural engineers will design one day, and one of the things you have to be thinking about is whether or not this product is designed in a way that's safe for consumers to use. So there's a million ways that the law interfaces with technology, and one of the reasons I'm standing up here is because knowing the principles of structural engineering is good, but knowing how they are applied in real life is even better. So I've always thought that education is sort of the accidental byproduct of discussion fueled by curiosity. So one of the things I'd like to say up front in our get-togethers, the 12 get-togethers that we have, is that what people get out of this course will depend upon what you contribute. There's no tests, there's no memorization, there are no quizzes, there are no exams, there's nothing. The only thing you have to do in this course in order to learn is to show up and ask questions. Everyone out there has questions. Everyone out there is, I'm sure, going to be thinking from time to time, well, what about this, what about that? And that's the way we all learn. So one of the reasons I think attendance is important is not for me. I know I don't keep track, although I guess I am supposed to keep track of who's attending. Speaking of that, here are the sign-up sheets. But I think attendance is important because out of respect for the other students in your class. It's how they learn. They're not going to learn from me. They're going to learn from your questions, and you're going to learn from your questions. That's how really education sort of accidentally happens. So I encourage you to ask me questions, not just for you and I to have a dialogue, but it's a dialogue that involves the entire class. And light bulbs, I see them, I don't know if you can see, you're not teaching, but I can actually see the light bulbs going off over people's heads from their expressions when someone asks a question. Yeah, I can see on somebody's face, wow, I was going to ask that question. I can actually see learning take place in the classroom. So, if you have a question, I really encourage you to participate because you will be helping somebody else in the class. And it's for the same reason that I wear a bow tie. You know why I wear a bow tie? I wear a bow tie out of respect for you. I wear a bow tie into the courtroom out of my respect for the fact that I'm going into a place where justice is being done. I want to show respect for the place that I'm walking into. I wear a bow tie to this class out of respect for you and out of what is going to be going on in this class. And speaking of this class, it's always had a pretty good reputation among the students that have taken it. Dr. Eager shared some of his class evaluations with you the other day. I want to share with you my favorite evaluation from last year. No hard feelings, at least they said they loved the class. But it hasn't discouraged me. I have gone out and bought a few new ones, but I still wear them out of respect for you, okay? The reason there's pastries in the back of the classroom, excuse me, you can tell where I'm most comfortable. But the reason we have pastries today is because I have a thing in my office. When I started my office 34 years ago, whether I could afford it or not, every Friday was Free Bagel Friday in my office. So for 34 years, every Friday, my employees get free bagels and cream cheese and butter or whatever. And so I haven't stopped that in 34 years, and it's a tradition that I'm carrying over into this classroom. So every Friday here will be, well, at least the equivalent of Free Bagel Friday. They used to have a bagel place nearby, but they closed. So now you have to settle for Flour Bakery. And I hope, by the way, everybody gets some while we talk today. So that's the kind of like the little introduction that I had for you. And I told you I was going to tell you a story, so I'm about to start to tell you that story. But before I do, can anybody tell me what concept they have or what idea they have when I say the words intellectual property to you? Does anybody know what intellectual property is? See very few light bulbs going on. Okay, yes, please.
Like anything that you
You got it. You got it. It couldn't possibly have a better answer than that. You know, intellectual property, it in some ways, it's kind of an amorphous or inchoate sort of concept, but you really can think of it like buying a house. It's as real as buying a house. Your rights to an invention, your rights to the fruits of your intellectual creativity is as tangible as buying a house. So think of it as a piece of property that you can own. And as we'll find out as time goes on, it's something that only becomes protectable when it's expressed in a tangible form. So if you just think of it, okay, since it's not expressed in a tangible form, it's not protectable. You can't protect ideas. You can't protect thoughts. You know, if you can think of a better mousetrap, that's not protectable until you express it in some way in tangible form, a diagram, a writing, a drawing, anything like that. But whether it's written and is copyrightable, or if it's a design that's trademarkable, or if it's an invention which can be patented, all of those are examples of intellectual property. And that's what we're going to be talking about here, because you'll either be creating an invention or somewhere along the line writing code to perform some function on a computer, or maybe some of you will come up with a design that that needs trademark protection. We'll be covering all those things just so that you'll know the basics, so that when you go out into the real world, somebody doesn't take advantage of you. So speaking of being taken advantage of, I wanted to tell you a story that will really provide a frame of reference for the entire class, for everything that we learn during the next 11 sessions. Really will all sort of be tied to this particular story that I'm going to tell you. It's one of those stories that happens once in a lifetime, and I thought it would be just perfect for this class, because as the story unfolded to me, and as I thought it through and worked the story, I thought, what a perfect sort of avatar for what we're trying to do in that class. And I think that I'll, with the permission of the people who were involved, tell you the story. It involves a student here, or let me just say, a student at a very famous technical university someplace in the city of Cambridge, Massachusetts. And she was enrolled as an undergraduate student, let's say in the Department of Materials Science and Engineering. And she and the other students in her class were studying the characteristics of a particularly highly reactive compound, which will remain nameless, because there are disclosure things that I need to be cognizant of. But let's say it's the most abundant metal in the Earth's crust. Okay? And the class was studying the reactive qualities of this compound. And the purpose was they were trying to get a reactor, a liquid flow reactor to operate. And so they were taking this compound, and they were dipping it in various solutions. And one day they put it in a gallium solution, and they were watching how this compound, this very highly reactive compound, reacted in gallium, because they were trying to get it to flow through the pipes of this reactor, and they're having trouble. It kept freezing up the pipes, okay, because of the temperature at which where it flows. So they had an idea to introduce another solution into it, to introduce indium into the solution in order to bring down the temperature at which it would flow. But that kept gumming up the works too. So the gallium-indium solution for this reactive compound really didn't turn out to work so well. So what they decided to do, which bright engineers do, is they say, well, rather than try to get this compound to flow better, we'll just put heaters on the pipes. And so they just sort of abandoned the idea of trying to get this compound to react the way they wanted to. They just made the machine work around the characteristics of this compound. And so they took the gallium-indium saturated element and they threw it away as hazardous waste. And they told our student to get rid of this stuff. And she grew up on a farm, and she was taught by her parents never to throw anything away. And so she took the saturated indium gallium saturated compound and she put it in a plastic container and just stuck it in a drawer here at MIT. And she went back to work on the class project, and she was designing the heaters for the pipes to get this liquid flow reactor to work with the old method, and had just totally forgot about this stuff. A few weeks later, she was cleaning up the lab, and she remembered that this stuff was sitting in one of the drawers, and she opened up the cabinet, pulled it out, opened up the plastic case in which it was stored, and she noticed that it turned all black, which indicated to her there had been some kind of chemical reaction that took place that she didn't understand. And so on her own time, she took this hazardous waste and she began to study it. And one of the things that she did one day is she took this and she dropped it in a bucket of water. And it began reacting like crazy. This is something that nobody expected. She had talked about it with her professor. She showed the professor what had happened. He didn't understand what was going on. So they were really interested in what had happened. And she particularly wanted to sort of understand this better. So she built a reaction chamber and she reproduced what she had done before, and under controlled circumstances was able to understand the chemical reaction that was going on. She found out that it was that when by dropping this very common element into water, it produced a great deal of hydrogen and heat. In fact, I can even show you. That's the reaction chamber that she built here at MIT using her own stuff on her own time in order to study this particular chemical reaction with this gallium-indium saturated compound. And this is what she was able to measure what was being produced. She was able to measure the amount of hydrogen it was producing. And by the way, I don't know if you know it, but there's only so much hydrogen in the atmosphere, and hydrogen is in great demand. People have been looking for ways of manufacturing hydrogen for a long time, at least in a cost-effective way, because we use hydrogen. Can you think of things that we use hydrogen for? Any ideas? What do we use hydrogen for? Why don't we have a hydrogen-fueled automobile station on every corner instead of a gas station? And because hydrogen is really expensive, at least compared to fossil fuels, gasoline, to produce. If we could come up with a little box that could create hydrogen more cheaply than gas, you'd see, instead of gasoline stations, you'd see hydrogen stations, and we'd all be, driving, flying cars with hydrogen. But so it's something that's been a great deal of interest, but has really stumped scientists for a long time. So anyhow, she was able to refine this and understand it better, and she showed it to her professor, and the professor thought this was really fascinating. And consistent with her obligations as a student at this famous technical school in the city of Cambridge, she notified the technology licensing office and her professor that she intended to file a provisional patent on this discovery. And they said, that's a great idea, I think it's wonderful, go ahead. And since there were no government funds used in order to create this device, she was able to claim ownership of it. MIT has a piece of the action every time you invent something here where you use substantial MIT resources in coming up with the invention. But if you grab some hazardous waste out of a dumpster and sort of and make something on your own time, that's not considered substantial resources of MIT. So MIT doesn't get a piece of the action. I don't know why I keep doing that. I apologize, but I think it's because the table's not close enough to the projection machine. Anyhow, so she graduates with her undergraduate degree, and then she goes ahead and talks with her professor, a famous professor in the material science department of this famous university, about making this part of her PhD thesis. And so she discussed it with her professor, and they work on it together, and this becomes the subject of her PhD thesis. Meanwhile, her patent is sort of wending its way through the United States Patent and Trademark Office. You know, she wrote up the application, wrote the claims herself, sent it into the patent office. There was a patent examiner that was having a dialogue with her about the invention. She did the study herself of the prior art to show that this was certainly, you know, an advancement and an invention that was worthy of protection. So all that was going really well. Meanwhile, you know, she worked on her PhD thesis using this invention, eventually it became the foundation of her doctoral thesis. Lucky for her, MIT offered a fellowship to her to study this. And I have to tell you, there's a lot of commercial, you know, upend to this thing. So it's not necessary when MIT offers to fund an invention of yours, it's not always out of altruism. It's because that there are commercial aspects to it that can be exploited. And by the way, it's not a bad deal because MIT, under the arrangements that they have, shares any royalties with you. So while MIT agrees to pick up the cost of prosecuting the patent, and that means filing the application, drafting the claims, hiring lawyers, not me, but other types of lawyers to draft the claims and sort of, you know, bring it through the patent process, which can take sometimes years, and then market it commercially. You know, that's the kind of thing that takes money, and you probably can't just go to your parents and say, hey, can I have $50,000 to bring this patent up to a point where I can practice it? But MIT steps in and says, okay, we'll do that for you. And the deal is that we have to, you know, we share in the royalties, which in many cases is a very equitable arrangement. So that's what she did. Again, she perfected the invention, went to work on her PhD, got her PhD, and during this time was in a dialogue with the Technology Licensing Office saying, you know, what's going on with this? And they said, well, we're going to market it in Europe, we're going to market it in China, we're going to market it in South America. We're going to do our best to find a commercial way to exploit this commercially. This was great. The student was really happy about it. Meanwhile, the student she came up with other associated patents because she really became very good at this particular technology. And one day she starts hearing from the Technology Licensing Office that, well, they can't find anybody interested in this patented technology. So, you know, we're not gonna help you anymore. And in which case, you know, she said, okay. She didn't have anybody that would buy it, but she believed in herself, and she believed in her invention. And so, with money that she could scrape together from her parents and from others, she went to the Technology Licensing Office of this famous university and said, if you don't want to further develop this technology and try to commercially exploit it, I'll buy it back from you. Because what happened was she had filed an initial provisional patent, and in order to prosecute a patent and convert it from a provisional into a utility patent, you have a certain amount of time. And so this became the subject of her doctoral thesis, under the deal with MIT, in order to qualify for the fellowship, she had to allow her provisional patent to lapse and for MIT to take over the patent. In other words, file an application in their name as the inventor. And by the way, on a provisional patent or a utility patent application, you have to disclose whether or not any government funds were used. Because if government funds were used, that has ramifications. The government then has an interest. They call it marching in rights with a patent. And when MIT filled out the patent application and filed it with the United States Patent and Trademark Office, they represented, they certified, they stated under oath that there were no government funds used in this invention. Did I say MIT? I meant this famous university in Cambridge. She paid this. So she paid the technology licensing office of this university $50,000. And they executed a document called an assignment of rights. And it basically said, any rights that we have to this technology, we're giving back to you. You gave it to us, now we're giving it back to you. They took that $50,000 check and put it in the bank. And then she went to work exploiting the patent, and wouldn't you know, she came up with some very valuable commercial applications for this. Commercial applications that are important to the defense industry. And you know, they have all the money in the world. And as it turned out, 18 months later, she was very close to making a deal that would be in 7 figures when it came to the licensing of this technology. And she was actually working with some contractors who also work with a famous laboratory, famous for putting people on the moon and doing other things like that, that also is associated with this famous technical university. And they got wind of what she was doing. And they decided they wanted a piece of the action. But they knew that they didn't own any of this technology. But that didn't stop them. So they colluded. Have you heard that word before, recently? They colluded with this famous technical university's licensing office to try to get this technology back from the student. And one day the student gets a letter in the mail from the university saying, gee, we made a big mistake. Actually, there was government funding with the class where you developed this invention. And it was secret. We didn't tell anybody about it. But trust us, there was government funding there. And so now you have to give us back the technology, the patent on this technology. And what did she do? You're in that position. What do you do? That possibly is the best answer you could have ever given. Absolutely. You know,
I'd say hire the right lawyer.
hire the right lawyer. Right. Not me. Hire the right lawyer. Hire the right lawyer. You know, so many times, and you know what? Not only is there a gap in the curriculum here at MIT when it comes to intellectual property for students, but I have become convinced that there's a gap in the knowledge amongst the faculty at MIT when it comes to intellectual property. Because she did what very few students or faculty at this university do, is she questioned the university. They stuck an agreement under her nose and said, sign it out of respect for us. And she said, that doesn't sound right. And she came to our office. So what MIT then did, I guess it's pretty clear who this famous university is, so I'll confirm. What MIT then did is they said, well, not so fast. This class was funded through Beaverworks that received money from the Office of Naval Research. And while we can't tell you how much it was or when it was, we believe that some of this funding was part of this course. And therefore, under the Bayh-Dole Act, we own the technology. Has anybody ever heard of the Bayh-Dole Act? All right. Well, you're about to hear about it. Remember Professor Eager told you there's one thing you need to take away from a class lecture? Here it is. I'm telling you what it is, okay? There are 4 words that you need to write down about today to know everything you need to know about today. The Bayh-Dole Act, or as it is known to people like me, the University and Small Business Patent Procedures Act of 1980, 35 United States Code Section 201, all right? And that's basically a law that Congress passed that says simply this. When government funds are used in order to make an invention, the taxpayers of the United States, in return for the investment that they make for you to develop this technology, get a piece of the action. It's only fair. And on its face and in concept, it's a wonderful, wonderful statute. It's fair. It protects the taxpayers. It protects the inventor. Everybody gets to share. Nobody gets everything, but everybody gets something. And I think it's one of the few things that has come out of the Congress in the area of intellectual property that makes any sense. And I'm going back to 1780, okay? And if there's any statute that you need to learn, or any law that it informs you as students and as inventors, this is the law that you should know. If you come out of here with knowing just one law, this is the law you should know. Because this is the law that gives the university and the government rights to your invention, if it applies. But this says that in order for it to apply, there has to be substantial government resources or funding involved. Now, if you on your own time take hazardous waste from a dumpster, literally, and develop it on your own at a sink at MIT using a bucket and water, does that sound like substantial government funding or assistance? Those shaking your head are absolutely correct. In fact, the Secretary of Commerce has written regulations interpreting the Bayh-Dole Act, which are really fair. You know, the overwhelming presumption in our law, going all the way back to the Constitutional Convention, is that the and by the way, when I say that's the Constitution I'm talking about. You know, in addition to free speech and freedom of religion and, you know, having the right to remain silent, one of the other rights conferred upon you as citizens is the right to have your intellectual property protected. The people that wrote the Constitution were inventors themselves, and these were the rights to protect your intellectual property were on the same level as far as they were concerned as your right to free speech or freedom of religion, because they knew that for a society to advance, there has to be a matrix of laws that allows inventions. What did Professor Eager say an engineer is? What's a scientist and what's an engineer? Come on, it was only yesterday. What's the difference between a scientist and an engineer? Yes, sir.
A scientist explains why things are, while an engineer creates things that haven't existed yet.
Right. And I put a slightly finer point on it, that makes people's lives better. And the founders were concerned with making our lives better. They wanted to advance our society. They wanted to encourage the sharing of knowledge. They wanted to encourage development. They were smart people. And they put right in the Constitution, we'll go over it the next class, this right to have your intellectual property protected. So going all the way back to the Constitutional Convention where these things were discussed, intellectual property rights have been foremost in the minds of the lawmakers of this country. And I I'll say it again, the best thing that Congress has written, with possible exception of the AIA, which is the America Invents Act, which was also came out the same year this did, was one of 2 or 3 things that the Congress has got right when it comes to intellectual property. But as with any, tool, it depends on the use to which it's put as to whether or not it does society any good or it does harm. In the hands of the wrong people who make up things like there was government funding, very secretive government funding that you didn't know about and we never told you about, but now we believe was there. Why would a university make those stories up? Why would they want that technology back? Yeah. Do you know that every college and certainly every technical university in the country has, do you know what a patent portfolio is? You've heard of bank accounts where you keep your money. Well, a patent portfolio is a list of patent technology that you own from which you receive royalties. I'm sure a couple of these buildings were built on the return on investment for patent portfolio. And by the way, there's nothing wrong with that. I mean, that's a legitimate way of exploiting the knowledge that you pay to develop. There's nothing wrong with that. But sometimes fattening the patent portfolio seems to be more important than disseminating knowledge and supporting the efforts of students, at least to this observer's eyes. And since I only care what you think as my client, I'm your advocate, all I care about is what you care about. That's how I see this particular case unwinding. And what happened, of course, was that we pushed back. We said, this double secret probation government funding thing is a bunch of nonsense. Go away, or you'll deal with us, all right? And how it plays out, I think we're going to find out during this term, because I've really basically brought you up to the point in the story where we are right now. Whether or not the university ends up doing the right thing remains to be seen. But what this story illustrates is everything you need to know as a student. You have to be conscious of what rights you have. You have to be conscious of the forces that exist in order to take those intellectual property rights away from you. You have to know enough to question when somebody sticks something under your nose and say, sign this out of respect for the institution. The first thing that should come out of your mouth when that happens is why. And I started to say that I think another gap in the education here is with faculty. Faculty sign on to agreements in this university just like students do. Did you get, as part of your student handbook, some disclosures that you signed? Did anybody read them about what you were giving away when you signed these things? Hopefully you read them. Okay.
Only the graduate students that were on RAs.
Oh, okay.
The undergraduates you shouldn't get it.
Okay.
I'm not saying they wouldn't put it under your nose, but undergraduates are paying tuition.
Yeah, that's right.
And therefore, anything you develop as an undergraduate is yours. A graduate student, if you come here with your own funding, it's yours. If you are funded by MIT for your graduate studies, it belongs to MIT, and they can force you to sign it.
Yeah, and sometimes it's a good deal. Yes?
Can I follow up on this? So, sorry, I'm directly involved. So, does this apply also for inventions that you do on your own time?
That's an interesting question, and that question is now being, Steve will probably get into this. Historically, on your own time, it was yours. The institution and the administration is now sort of changing their stance on that. And when Steve says some of the, refuse to sign something, I refused to sign the latest thing 3 years ago because I read it and I thought, What? I mean, they may be taking the rights to any book I write. Okay? It was too general.
What do you mean maybe? What do you mean maybe? I have the answer to your question. Believe it or not, I may not be a good lawyer, but I'm a prepared lawyer. So I brought in the seminal case, a copy of the seminal case. Don't bother reading it now. But the case of, everybody refers to it as the Stanford case. It's not really the Stanford. It's Leyland Stanford Junior College versus Roche Molecular. This is a case that was just decided in 2011 by the United States Supreme Court. And in that case, I think is the answer to your question. There's a whole analysis, and the court, this is one of those cases. By the way, do you know how many, I don't know about, this is what lawyers do in law school. We read probably for every class that we go to, maybe 25 or 30 of these, figure 20 classes a week times 3 years. This is what I do. So let me synthesize it for you. There's a wonderful discussion in this case by the United States Supreme Court where it goes through the whole history of patent law. That's why I'm handing it out to you, because it really teaches you everything that you need to know. But what it says in answer to your question is, the founders believed that the rights to an invention belong to the inventor. That's the default position under the law. Now, Congress, in exercise of its Article I powers, can create legislation that slices some of that right to ownership off. If you think of an inventor's rights as a big loaf of sunbeam bread. Does anybody know what sunbeam bread is? I feel older and older. Sunbeam bread used to be the bread of choice for peanut butter and jelly sandwiches that I took. Yeah, exactly. It had zero nutritional value. The good thing about sunbeam bread is you could make a ball out of it. It was so full of yeast and sugar, and it was just horrible. But anyhow, think of it as a loaf of bread. Let's call it artisanal whole grain bread for you. And if you think of that as the rights under the Constitution that you have to inventions as a citizen, every now and then Congress can slice a little bit off for a good reason, so long as it's constitutional. And when it came to slicing a little bit off of the loaf of bread so that the taxpayers could get a return on their investment, then that was okay. That was considered constitutional. That's the Bayh-Dole Act, actually. But what the court said is, look, our fallback, our default position is the rights to inventions belong to inventors. Unless Congress has sliced off a very specific piece for a very limited reason. We allow them to do that, but we can't look at these things expansively. And we're not going to allow institutions like Leyland Stanford Junior College to expand those rights. By the way, anybody hear of the Crispr litigation and the Crispr gene editing? Well, that's been the subject of all kinds of litigation, and that involves, the constitutionality of some of the laws that Congress has written. And what the Supreme Court says is we're going to look at these things very narrowly and favor the inventor as much as possible. But that doesn't mean the universities look at it this way. And when it comes to the real Stanford and the real Harvard and a lot of other universities, what they've been doing is they've been looking at this in a much broader way, and they've been urging that interpretation on their students and on their faculty so that they fatten their patent portfolios. But anyone that asks me to sign an agreement that expands the rights that the Supreme Court says they have has got to give me a good reason for doing that. Why should I give you more rights than the Supreme Court says you have? And unless you answer that question to me satisfactorily, I'm not going to sign anything, whether I'm a faculty member or a student. Because this case says, and you'll read it in there, it says, the rights belong to the inventor except for very specific instances that Congress has articulated, unless there is an agreement between the parties. And somebody, when this decision read those words, unless there is a private agreement between the parties, and the emails started going out to their big law firms, and some associate way down the food chain of you know, one of these huge 500-member engulf and devour law firms who just out of law school started coming up with phrases to include in all of the intellectual property agreements that their university customers have, that widens that door beyond which the Supreme Court, because the Supreme Court said, okay, if you want to privately agree to more, you can. And so universities have been treating that as that can, they treat it as a must. And so you've got to be aware of that. It's not always, don't ever sign anything out of respect for anybody, okay? Sign it only because there's a good reason to sign it and because you've had the foresight to ask why when somebody asks you to do that. We'll go into more about intellectual property and its origins. And you know, when I'm going through the origins of this stuff and I talk about the Constitution, I want you to understand that there's a reason for that. It's not just old, musty old history, but whether or not something is enforceable and being able to understand why certain things are the way they are, you need to know something of the historical origins so that you can make sense of why Congress does the things they do and what rights you have as an inventor. The more you understand about where these things come from and why they're written, the better you'll understand how they apply to you. So that's my story. Take the course home. Has everybody, the case home, has everybody signed the sign-in sheet? Friday is the next meeting. I'm going to go into some of the next meeting with me, sorry, and tomorrow's Wednesday, the Mercedes-Benz guy. I'm going to come to that lecture because I think that's, you know, like I said, I almost got run over by one of those BMWs the other day, and I want to find out, you know, who would have lost the physics of that encounter, me or the lightweight vehicle. So yeah, take some food with you if you want. It's here because I promised your parents you'd eat something.